Logarithms and logarithmic functions. Start off with your state standards, followed by your success criteria. Today you need to be able to explain the meaning of a logarithm with base b, evaluate logarithmic expressions, and you need to be able to graph logarithmic functions. You do have a couple vocab today, and these are new vocabulary terms that you may not have seen before, so make sure you get these in your notes and you pay close attention. Definition of logarithm with base b. Let b and y be positive real numbers with b not equal to 1. The logarithm of y with base b is denoted by log base b of y and is defined as log base b of y equals x, if and only if b to the x power equals y. So basically, logarithms are inverses of exponential functions. You know, we've been working with exponential functions. So now we're going to start working with logarithms, which are inverses of exponential functions. All right, the common logarithm. A common logarithm is a logarithm with base 10. Right? So if it has base 10, you may assume that is there. So if it just says log of x, you're going to assume that is base 10. Right? So this is important to know. It's kind of like a coefficient. If you have an x and there's no coefficient, you assume that to be a 1. Well, with logarithms, you assume this to be a 10. So log base 10 is your common logarithm. Natural logarithms. So in the last lesson, we learned about e. And so a natural logarithm is a logarithm with base e. And it can be noted as log base e of x equals ln x. So when you see ln, that represents your natural base, which means the base is e. Common logarithm is always going to be log. Your natural logarithm will be noted ln. So you may see it as log base e of x, and that's equivalent to ln x. But again, when you see the ln, that is assumed to be base e. That's called your natural logarithm. When it comes to graphing, the logarithm is the inverse of an exponential function. So again, the inverses, remember, is a reflection across the y equals x line. So this is your dotted dashed black line here that goes through quadrants 1 and 3. You can see that this is your exponential function. This is your logarithmic function, which is the inverse. It's a reflection across the y equals x. Same thing here with exponential decay. And then you have that reflection here for the logarithm as well. It's still a reflection across the y equal x. Example 1, rewriting logarithmic equations. All right, so definition here, very important to know. You should be able to go from logarithm to exponential and exponential back to logarithm. So log base b of y equals x if and only if b to the x power equals y. So when it says rewrite equation in exponential form, all we're going to do is go from this form to this form. So log base 2 of 16 equals 4. That's the same thing as 2 to the 4th power equals 16. So you're going to go from here to here and back to here. All right, so log base 4 of 1 equals 0 is 4 to the 0 equals 1. Anything to the 0 power equals 1 if you remember properties of exponents. Log base 12 of 12 equals 1. So 12 to the 1st power equals 12. And then log of 1/4, log base 1/4 of 4 equals -1. So we're going to have 1/4 to the -1 power equals 4. Again, properties of exponents, you know when you've got a negative exponent, it will flip this or bring the denominator to the top. So 1/4 to the -1 equals 4. Example 2, rewriting exponential equations. So rewrite each equation in exponential form. So again, using the same definition, this time we're given exponential form and we have to write it in logarithmic form. So look at the base becomes the base here, and then the exponent becomes the number it's equal to. So I'm going to have log base 5 of 25 equals 2. And rewriting b, I'm going to have log base 10. Remember, if you have log base 10, you can assume that 10 is there. And g of 2/3 equals 4. Sorry, not g, 8. I don't know what I'm seeing there. So that's log base 8 of 4 equals 2/3. And the last one, 6 to the negative 3 power equals 1 over 16. So it's going to be log base 6 of 1 over 216, and that equals negative 3. Example 3, evaluating logarithmic expressions. Evaluate each logarithm. All right, so we know that log base 4 of 64 equals x. So 4 to the x power equals 64. So what power is that? That would be 4 to the 3rd power equals 64. So you could say 3 would be when you evaluate this. All right, so there is an easy way using your calculator to do this as well. If you go to math and you scroll all the way down, or you can scroll up. I usually scroll up because it's faster. So you go to log base and you can enter any base in your calculator. So if I want to enter log base 4 of 64, then that will give me my answer of 3. Now, you do have a log button here, but if you use this log button, this is assumed to be base 10. All right, remember the definitions. So when you have a common log, that is base 10. And when you have a natural log, it's base E. So this log is always going to be base 10. ln is always going to be base E. If you have a logarithm with another base, you have to go to math and you have to find the log base button. The log base button allows you to enter any base in there. So for B part, we could enter 5 and 0.2. And what does that mean? 5 to the negative 1 power equals 0.2. Well, 5 to the negative 1 power gives you 1/5. 1/5 is equivalent to 0.2 or 20%. So this is going to be negative 1. 5 to the 3rd power equals 125. So it must be a negative number there as well. So let's say 1/5 to the negative 3 is going to equal 125. Again, you can check yourself here. Math, log base button here. And we're going to do 1 over 5. So put your fraction in as the base. And then 125. And that gives you negative 3. And then 36 to what power equals 6? Well, the square root of 36 is 6. So that means it has to be the 1/2 power. So this one is going to be the 1/2 power. So if you go math, find your log base button, 36 0.5 or 1/2. Example 4, evaluating common and natural logarithms. Evaluate using technology. Round your answer to 3 decimal places. All right, so this is going to be our common log. And ln, remember, is our natural log. So that means you can use the buttons here on the side. So if I go log 8, again, that assumes it to be base 10. And it will give you an approximation of what that is. So it says to round to 3 decimal points. So it's going to be 0.903. All right, your natural log button, you've got an ln button assumed to be base e. So natural log of 0.3. And I hit enter. And it's going to give me negative 1.204 because this is a 9. You're going to round that to a 4. So negative 1.204.